Example 2, verify that negative 2 cotangent x equals sine x over 1 plus cosine x minus sine x over 1 minus cosine x. All right, as we get started here, let's go back to the four strategies. The four strategies from lesson 5.1, which change all functions, trig functions of sine and cosine, to use Pythagorean identities, to factor, or to apply conjugates. That's actually what I'm going to use here, because this looks like a conjugate. They have a fraction with a minus b and another with a plus b. What am I talking about? Let's look at it. This is in the place of a plus b. This is a minus b. I want to apply the conjugates, which means if I go over, and you remember how we start with the complex side. The complex side here is the right side. So I'm going to start on the right. What I'm going to do is I'm going to take this right side, and this one needs to be multiplied by what we call a minus b, which is 1 minus cosine x, because that's what it does not have. The denominator does not have that on the left, but does have it on the right. So it started off as 1 plus cosine, and I'm going to multiply by 1 minus cosine. Notice, technically, mathematically speaking, I'm multiplying by 1, because this divided by this is 1. But I'm going to do this, so now they have both denominators. Over here, this sine x is going to be, multiplied by 1 plus cosine. Now, the reason I do that is to get this denominator, which currently is 1 minus cosine, to also have 1 plus cosine x. Okay, now when you multiply conjugates, the reason why we do this is this will simplify to become 1 minus cosine squared. You square the first and the second. So it becomes, when I simplify this, the denominator, I'm going to make it one denominator because these are now common. It'll become 1 minus cosine squared x. Now if you want to know how do I get that, 1 times 1 is obviously the 1. Then you'd have a negative cosine, but this would be a positive cosine. They cancel each other out. And then cosine times the negative cosine is negative cosine squared. Now up top, I'm just going to distribute here. So I'll distribute these. And so we would have sine x minus sine x cos x. And then over here, you take the negative sign and you distribute that through. Minus sine x minus sine x cos x. Now when I simplify here, notice these two go away. They're opposite to one another. I'll slide down. Okay, and I'll extend my denominator, or my division symbol. And notice I now have 2 negative sine x cos x. Okay, so I can simplify this by making this negative 2 sine x cos x, because there's 2 of them. But notice on the bottom over here, this comes from the Pythagorean identity. I have a squared and a 1. So I go to the Pythagorean identity. The squared and the 1, and it has the cosine, is this first one. So I'll come over here, and I'm going to write the Pythag. And as a reminder, it is sine squared theta plus cosine squared theta equals 1. As it relates to this problem, we would say that sine squared theta equals, I'm just going to subtract the cosine across, 1 minus cosine squared theta. So that's what I'm going to substitute here. This next one would become sine squared theta on the denominator, or sine squared x, since this is dealing with x. And the numerator, we said we could simplify as, do you remember? Negative 2 sine, I'm going to write it black because that's what I was doing in black. I was simplifying the numerator. Negative 2 sine x cos x, because I have 2 of those, 1 and 2. All right, now, this is multiplication. You see how on the top is multiplication, and on the bottom is division. Can I cancel factors? Yes, you can. Notice I have 1 sign up here and 2 signs down here. That'll take out one of the signs with one of those signs. So this would simplify to become negative 2 cos x over sine x. And now we come to what's called the quotient identity. A quotient identity is that one when you have division specifically involving sines or cosines. This is x over y, psi y cos x, psi y cos x. So this is x over y. Well, the song goes psi y cos x, tangent is y over x, which means cotangent is x over y, also known as cosine over sine. So I could write this right here using the quotient identity. and say that that is negative 2 cotangent of x, which is what we set off to prove. We have verified that negative 2 cosine or cotangent of x is equal to all that. So this is my answer here, and I usually, when we're simplifying or verifying, I'll do a check mark if I get to the end. You got it correct, so I did that there. Now, just to fill in your steps, this I did not write it down, but this step right here came from conjugates. This first thing I did was we applied conjugates. Okay, and that was that a squared minus b squared equals a minus b times a plus b. That's what I did here first. That was the first thing we did right here. The second thing we did here is I simplified, and I also did the Pythagorean identity. So let me do this here. Pythagorean, I'm going to put a 3, and I'll say that we changed that 30 right there. Step 2 in here was that we simplified. Actually, I'm going to move this over here, make it easier to see. The second step that we did was we simplified the numerator here. And that's what I did there. And then we came over here, and again, I did another simplification. That was the fourth thing we did. And so that's step 4 here. And then the fifth thing is we did the quotient identity. And that's what happened right here to get our answer. Now, let's look at the next one for you. If you have this, I'd recommend you start on the left. And again, this time, though, don't try conjugate. You could, but yeah, go ahead and try conjugates. That's actually going to be a pretty good plan. Try conjugates, see what you come up with.